All right. Well, this is awesome. It's been a great conference. We're getting close to the end, but I hope that you guys are still awake, because I got some fun stuff that I want to talk about. And I even brought a little friend here to give away at some point in the talk, so be ready. Just say that. All right, I'm going to talk about APIs. We had some talks about APIs and HTTP yesterday, and so I kind of designed this to be complementary to those talks and to go deeper into certain areas, especially on the client side of API. So we're going to talk a lot about Guzzle and Swagger, along with Lumen and parts of the Laravel ecosystem. So my name is Jeremy. I'm currently a product architect at McGraw-Hill Education, which has been around a really long time. They started in the late 1800s, and they've been publishing books and textbooks for a long time. And in the past 2 decades, they've transitioned into more of a digital company. We like to call ourselves a learning science company because we like to develop things that help people learn and help teachers teach. I'm Jeremy Amaya on Twitter, if you want to find me there. And I also help organize the Pacific Northwest PHP Conference up in Seattle, which is in September. If you want another opportunity to see Taylor or Adam speak, they will both be speaking at that conference as well. So check it out, pnwphp.com. All right, so I think right now is actually a really fun time to be a developer because we get to work on APIs, microservices, we get to work with REST. We've got all sorts of stuff that we can put in the cloud, and there's a lot of fun things that we can do. And I still think that developing APIs is pretty hard in general, because there's kind of this struggle between the client side and the server side. And I don't feel like we have all the tooling that we need to really make it as smooth as possible. So I know yesterday, Amanda talked a lot about Lumen, so I'm not really going to touch on that. But the part of the example that I'll be using is a Lumen application that I was developing as part of kind of a proof of concept as I was doing things for this presentation. And what she told us yesterday I thought was awesome because she showed how the features in Lumen make it really easy to develop the business logic of your application. But there are so many other things about your API that you have to think about than just what it's doing. What it's doing is the most important part to your business, but all the other stuff is how you actually make it work and get people to use it. So I tend to kind of obsess over those little details because those are the things that I'm really interested in. So when I start up a Lumen API that I want to build, I get to the very first time that I'm going to write a route, and then my brain just explodes. Like, oh no, what am I going to do for this part? How am I going to implement this protocol? And I start going crazy. So just in the definition of a route, you have a ton of decisions that you have to make to decide how your API is going to work. So things like what HTTP methods you're going to use, what the endpoints are going to look like, what the payload's going to look like, what status codes you're going to return. There's tons of stuff to worry about, and the HTTP spec is pretty large. So who has read the HTTP spec? Raise some hands here. I want to see. I see a few hands. Okay. Yeah, who's read the entire Lord of the Rings? Okay, a little bit more there. So the HTTP spec is shorter than that, but not by much. Good point. All right, so let's make these decisions. Because I work in the education industry, thought I'd use a simple example from there. Building a gradebook application, our MVP is just going to let us do CRUD-type operations on assignments. We'll call it My Gradebook. So original, right? Well. So first thing we need to decide, what should the endpoints look like and which HTTP methods will we use? So the common ones are ones we've seen before. And yet, at the same time, I see people do really, really weird stuff with which HTTP methods that they choose. Most of the confusion is usually around put, post, and patch. So I usually think about it this way. Put is really replace. Whatever you put replaces the current record, or if it doesn't exist, creates it. Patch is a partial update. So you can update a record, but only update the fields that you want to. And post is for creation, or pretty much whatever the hell you want to use it for. Because people just do anything with patch, or with post, sorry. That's cool, because not every operation fits cleanly into a CRUD bucket. Sometimes you're doing different stuff, and usually post it comes in handy in those cases. So for our endpoints for this application, post assignments for create, get assignments for listing, and then we can get, patch, and delete assignments with a particular ID for reading, updating, deleting. Easy enough. Next, if you are curious on those outside cases where your operations that you want to do don't quite fit the regular REST mold, or if you have any other REST API design questions, this is an awesome book. Probably my favorite about API design. So it's called A Practical Approach to API Design by Keith Casey and James Higginbotham. I think that's how you say it. It's a cool name either way. And they also have a weekly mailing list called API Developer Weekly that they send out that has tons of really good articles if you're interested in API design. So this link and every other link will be in the 2 slides of really fine print on my slides at the end. So when I post the slides, that will all be there. All right, so status codes, that's another thing we need to decide. How many of you think that you know maybe more than 75% of the status codes by heart? How many of you only know 2 by heart? That's a lot of hands. So I'm going to give you a quick pop quiz. 503, what's the reason phrase? Service unavailable, good. Wait, Ben, you can't play. You gave the HTTP talk, that's not fair. Service unavailable, but down for maintenance is a different one, I think, right? Or can you use that same one? See, status codes are hard, right? All right, 201. All right, there we go. That was an easier one. Created, good. 429. Rate limit. Who said that one? Too many requests. Yeah, that's for rate limiting. Good job. All right, now a question that's plagued developers for ages. Should the API version go in the URL or in the headers? So this will solve by a vote. URL. Very confident, yes. Headers. Who doesn't care and just wants an elephant? Told you to be ready. All right, the next thing is, what do we do with the payload? Well, we can do application JSON, we can do XML. Who likes XML for their services? Hey, there's still use cases, but I think we're kind of a JSON by default type of situation at this point. But the question's deeper than that, because there's 100 different ways that you can do JSON. A lot of those have to do with the different specs that are related to hypermedia or HEDIAS, HAL, JSON LD, JSON API, custom stuff. There's a bunch of other ones that are kind of smaller in usage base, but they exist. How do you choose which one you want to use? Me personally, I don't know that I really fully believe in HEDIAS yet. I think there's still more to do in that area. If you are interested in doing one of these, I'd say probably your easiest paths are HOW. If you keep the recursion depth to like 1 level, because HOW is a recursive spec and kind of gets crazy. JSON API, if you implement maybe just a subset of it, it's pretty simple. But it can get complicated too. JSON LD is just really complicated by default. All right, what about authentication? That's always the tricky part for me. And it's usually the hardest part to get working when you're developing. Sometimes I do all the work on building the business logic and then come back later and do the auth because it's kind of hard. So I kind of put auth into 3 different groups. So I have a table up here that shows what type of credentials you need to apply on the first visit or the first request, and then on the second or subsequent request, and then whether or not SSL is required. And then I get some examples. So the first group, you need to pass some kind of ID and a secret every time. And an example of that would be HTTP basic auth, which is probably the easiest way that you can implement authentication. But you definitely have to use SSL for that, because you're passing a secret key basically in plain text, unless you use SSL. Another way you can do auth is kind of the token-based auth, where you have an ID and secret the first time, and then you get an access token. Sometimes there's a complex workflow to get that access token, like in the case of OAuth 2, if you're doing 3-legged OAuth 2. But then later, you can just pass the ID and the token until it expires. So OAuth 2, again, is an example of that. JOT tokens, which can be used in conjunction with OAuth 2. And the third type is where you pass an ID and a signature. And in this case, you don't actually ever send your secret key over the wire. You use it to create the signature, and you send the signature over the wire. And in most of these specs, you can actually do it without SSL. But you should still use SSL anyway. Like, you should just do that. Examples of that kind of authentication include OAuth 1A if you're doing just like a 1-legged type. I think it might be called 2-legged, but really it's the naming's weird there. Where you're not authenticating with a third party. That's easier. Signature version 4 from Amazon is a spec like this. There's also one called Hawk that's similar to this as well, and a few others. And you can implement those without SSL if you really have to, because they're signature-based. But really, you should use SSL anytime you're doing an API to make your customers comfortable. And beyond that, there are a lot of other things you have to think about, besides just the business logic of your API. You have to worry about everything in the REST and HTTP specs. Again, versioning, status codes, content negotiation. If you're doing hypermedia, you have to worry about how you're going to do that. Auth, if you're passing stream or blob type objects through your API, there's different things you have to do to make that work well. Pagination, idempotent operations, rate limiting, cores, response caching. Then you have to deploy the thing, make sure it stays up and responds quickly, and all that kind of stuff. There's a lot to it. I think APIs are really hard. But luckily, there are tools to help us. What was that right there? Oh, clapping. Oh, thank you. There are tools to help us. And so I want to talk about some of those, both on the side where we're implementing the API and also on the side that we're consuming the API. So one that I've been playing around recently with is called the Dingo API, which is an extension to Laravel and Lumen. And it provides a few features to help you kind of get your API up and running faster. It does some things to help with content negotiation. It has authentication adapters for JOT tokens and OAuth 2. I'm interested to see how that will compare to Passport. Now that's about to come out, so I'm not really sure how those compare yet. Dingo takes care of API versioning, and they do use the headers to do that. So it's an opinionated framework, and so if you want to put it in your URL, then you shouldn't use Dingo, because they won't let you. They also include tools for rate limiting. You can attach a middleware to your routes that will apply rate limiting that's easily configurable in your end file. And they also have some additional things for helping you build responses and transforming them the way that you want them to be. When you configure Dingo, there's a few things that you have to set, but they end up getting composed into what you use for the accept header, or what your client needs to use for the accept header, and what is ultimately your content type. And that's basically how they all come together to form a specific vendor content type for your API. Dingo comes with its own router, which extends the regular Laravel one and provides a version function, allows you to specify the version, and that hooks up to the content negotiation stuff. When that accept header comes in, it checks for the version in the header and maps it to the right route. So you can have the same routes in two different versions, and then it will pick the one that is the correct for what was specified. But inside of the closure for the version, you can do routing just like normal in Lumen, with groups or with individual endpoints. Let's see. So Dingo also comes with a cool response builder, and it also pulls in the Fractal library automatically for you. And this is just an example of how you might use that. I think the Fractal library is actually pretty cool. When I first saw it, I was wondering, what is this for? Can't you just use like array map or something? And it turns out when I picked it up and started using it, I'm like, okay, this is actually kind of nice. It makes it a little bit more organized and reusable code. So Fractal is a library that I believe Phil Sturgeon started and now is a part of the PHP League. And if we had a table that was defined by this migration for our assignments, remember we are doing a gradebook API here. If we had these fields right here, ID, external ID, name, points, due date, and then the normal timestamps, then we could create a fractal transformer that maps the properties that we have in our database to what we actually want them to look like when we return a response. And I'm kind of an advocate of when you have a JSON API, that you should use camel casing in your property name so it actually looks like JSON. So I've done that in this example. I've also renamed things. And instead of passing my internal API, I've mapped that external API to the ID field. That's generally a good idea, I think, depending on your situation. Because if you push your auto-incrementing ID out into your API, it kind of reveals information about your system. If you don't want people to know how many of a certain thing you have, then you shouldn't give them that information. Using something like a UUID can generally work out a little bit better. And so that's what I did here. And after the fractal transformer is applied, this is basically what my response would look like. So it's super simple, but it keeps those transformations encapsulated into something that you can reuse. And in case you're looking for a good UUID library, the Ramsey UUID library is definitely the best one, and you should use that one. All right, if you want to test out Dingo, my suggestion to you is to grab this project right here and to just load it up because it's already configured and ready to go, minus like putting your specific information for your API in there. I was able to get up and running with this in like 5 minutes, which is awesome. And it had all you have to do is Composer install and run the migrations and change your configuration to what you want to call your API. And it's got jot token auth and CORS middleware already applied to it. So if you want to test out that stuff, super easy to get up and running with this. Again, this link will be in my slides here for later. All right, so let's go through the wormhole to the other side, to the client side, and talk about what kind of tools we have there. We need to consume our API now that we have it built, or in theory. So there's different kinds of HTTP clients that can be used in PHP to consume APIs. You can use file get contents and stream context. Who's familiar with stream context? I'm actually curious. Because those are kind of an advanced thing, but they're kind of cool too. I saw maybe like 20 hands, I think. Good for you. They're pretty cool. And then there's curl. Who's used curl before? Who enjoys using curl? Much fewer hands. Yeah. There's the HTTP extension, which is actually pretty nice, but it is an extension. Sometimes you can't necessarily use it. Then there's also userland libraries. Buzz is an older one that was in the Symfony community for a long time. Requests is a popular one as well, especially in the WordPress community. And Guzzle, which is a really popular one these days, mostly thanks to the Laravel community. So that's awesome, thanks. So if you haven't heard of Guzzle, it is a really cool HTTP library. It's on GitHub, it's on Packagist. It basically is a very nice wrapper for curl and other stuff. It also works with the stream context. And you can create other plugins. I believe there is one for React PHP that is being used out there too, which is kind of cool. It's PSR 7 compliant. It's capable of doing concurrent and async requests. It's got a promises abstraction built in when you're using the async stuff. We're not going to get into that today, but I did a talk about that in ZenCon, and it was a pretty intense talk. So I have the slides on my speakerdeck.com profile if you're interested in that. But that's some fun stuff. And I checked today. Guzzle has over 5,700 stars and 32 million Composer installations, which is kind of crazy. So that's awesome. The basic usage of Guzzle is using the Guzzle client, which you have to configure when you instantiate it. So if we were going to use this with our API that we were working with, the My Gradebook API, we would need to set a base URI to point the client at. We'll just make the assumption that I went with basic auth because it was really easy to implement. So that's what that auth option is. Guzzle has that built in to, if you're using basic auth, it's really easy to do. Then you can also define all sorts of things about how you want your client to work. So in our case, remember that accept content type that we had to use for Dingo? We can apply that globally to every request that we're going to use with our client by setting it when we instantiate it here. So that'll just be set automatically for future requests. Then if we wanted to do a post request to the assignments endpoint to create an assignment, we could do it like this. The URL and the accept header are already set because we instantiated the client that way. And then we just pass in our parameters with the form params and option. And then we'll get back the response, and we can get the data out of the response. In this case, if we got a 201 status code, which is graded, good, then we would see that here. If we had implemented the post assignments endpoint as to receive JSON instead of URL or form encoded input, then, well, I'm missing a slide. At least I got it right. We would just change form params to be JSON, because JSON is another one that Guzzle supports, and it automatically serializes it the right way for you. So using Guzzle is pretty easy for just making requests to REST APIs. All the request options are documented on the Guzzle documentation, so you can see what else is supported by going there. That link is, again, the end of my deck. So let's go back to this client versus server thing. So we've talked about how we can build the API. We've talked about how we can consume the API. But there's really still nothing connecting the two together. Basically, the only way I was able to write the use of those Guzzle functions is because I knew what my API was, because I just wrote it. But anyone else using the API needs documentation or other things to make those connections. We've got to build a bridge between the client and the server. And that bridge is called Swagger. So Swagger is really cool. Swagger is a way to describe your REST API. It is, on their website they say it's a representation of your RESTful API. And I thought that was just kind of funny because the RE in REST stands for representational. So it's a representation of your representational API that's a representation of your data model. So we're getting pretty meta at this point with all these representations, but that's fine. Swagger can be written in JSON or YAML, and they can be converted back and forth. A lot of people like to author in YAML, but then publish as JSON, which makes sense to me because writing JSON by hand is a horrible experience. Swagger has a very large ecosystem already. It's been around for a few years. And that's led to a lot of tools being built around this format, which is why I think it's so cool, is because of the ecosystem built around it. So there's tools for generating API documentation based off of a Swagger document, for generating code. And there's also lots of other services like API gateways that can read your Swagger document and know how your API works just by reading your Swagger document. So Amazon API Gateway, which I think came out last year, has support for importing a Swagger document. They require you to put some custom things in there, so it's a little screwy, but you can get pretty close to configuring your gateway just from your Swagger document, which is kind of cool. All right, but Swagger does have a new name. As of this year, it's now called Open API Specification. And so they have a new website, openapis.org. And what's kind of cool about this is this has a lot of people behind it. Like, these are all companies that are kind of putting a little bit of money and time into the Swagger specification. So to me, this gives me confidence that it's going to be around for a while. There are people investing in this, which is good. So currently, the Open API group that works on the specification, they are working on a version 3 of the specification. So now is kind of a cool time if you want to get involved and learn about the specification to do it, because they're actually designing version 3 of the spec right now, and if you get in there and you participate, then maybe you can help influence how that works out. So definitely check out the Open API initiative. But I want to show how a Swagger document for the current version is actually structured. So we have, I'm going to break this up into pieces. I know, reading a JSON document along with me is probably not like the funnest thing that you can think of, but I'm just going to point out a few highlights in the document just so you understand what information is in there. So at the top is the meta information about the specification, and there's an info block that I kind of just cut out of there because that's kind of more descriptions about it. But the top section also has the version of Swagger, information about the base URI, what schemes are supported, what content types are produced and consumed by the API. So those can help a client know how they should work with the API. There's also, Swagger also has the ability to specify things about how the authentication works, but that part is actually kind of hard to understand, and it's probably outside of the scope for what we want to talk about today. But there is things for that, though I'm pretty sure that's something they'll be improving in the future. Another section in the Swagger document is the paths, and this is where your operations are actually described. So basically there's two levels. You have the endpoint, and every endpoint in a Swagger document has the / as a prefix. So if you just have a /, like in this case, that just means the root of the path. Of course, applied onto any base path that the document specifies. And then the next level is the HTTP methods. So I have a get @ and a post @ here defined. And in each of those sections, you specify what parameters there are and what responses there are. In the parameters section, it's basically an array of parameters. And this is kind of like where the cool stuff is. So you name the parameter, and then there's an in field. And that in field actually tells you where that parameter goes. It can go in the query. It can go in the path. So you can, when you specify your paths, you can use URI templating. It can go in the form data. It can go in headers or in the body. And that is really kind of, as a client-side consumer of the API, that's really the information that's important to know, is where do we put stuff? And the Swagger document allows you to specify all that. And then you can specify types as well as defaults and a few different validation parameters, minimums, maximums, and some other things. Then in the responses section, you can specify what types of responses should be expected from this API. And so normally you define multiple of these. One for like maybe the success case, and then a few for error cases. So this is keyed by the status code. So that means that yes, you have to, if you want more than one response, you have to use more than one status code. Makes sense. And you also notice that this has a schema property that has a weird, funky thing called ref. So this is what allows you to keep your Swagger document organized and not repeat everything over and over again. There's a section in the bottom, it doesn't have to be in the bottom, but typically in the bottom, called definitions. And those refs, like here, are a JSON path that points to that definition. And so you can use refs in responses and parameters and other parts of the document to reference other parts, so you don't have to copy and paste them all over the place, which makes sense. Refs can even actually go outside and into other documents if you want to. So when you have a Swagger document, that's when magical things are now available to you. So Swagger has a tool that they support called Swagger UI, and basically is something that you can set up to generate API documentation based on your Swagger document. And it looks something like this right here. You may have seen one of these before on a service that you've used or an example somewhere else. But that's one option for generating documentation. And some of these are pretty cool because they have the ability to let you test out the calls. So as long as the API is configured with cores and the way that you specify the authentication it fits in with what Swagger UI allows you to do, then you can even expand different things, insert parameters, and make the call and kind of test out the API from the docs, which is kind of fun. There's another tool that Ben Ramsey told me about yesterday that I was like, whoa, that's awesome. So I wanted to include that today. It's called Bootprint. It's an NPM package that it's kind of a generic, take a JSON document, convert it into HTML, and then there's different rule sets to accomplish that. So there's one that someone made for Swagger or OpenAPI. And so you can take a Swagger document, you can run bootprint on it, and it will produce a set of docs for you. And those look kind of like this. They're not as dynamic as the Swagger UI ones, but they still look fairly decent. I would imagine this is probably a bit more customizable as far as like the HTML and CSS that's produced. And it's pretty clean looking. So there's a couple tools like that that are available for generating documentation. But documentation still doesn't really make us cross the bridge between client and server. The bridge is there, but now we need to cross it. So that's where the code generation stuff comes in. So first of all, you need to create a Swagger JSON document. And like I said, I personally don't like writing JSON documents by hand. Not that much fun. So you could write it by hand in YAML, or you could use a tool like this. It's called Swagger PHP. And you can actually annotate your code, where that code is actually relevant. And the Swagger PHP tool will do a static analysis through your code and generate a Swagger document for you. And so that project is pretty cool. This is basically what the annotations look like. So I realized that it's not really perfect, but it is cool in the fact that it can live right there by what's relevant. So if I was creating a controller method for creating assignments, I can write all the information about that API right there along with it. So I can come back and edit both of them at the same time. The parameters look like this. When the Swagger thing reads through it, it parses all that stuff and turns it into the JSON format for you. So you can go from code to Swagger, but you can also go from Swagger to code. And I think maybe I did not name this heading of this slide correctly. It's supposed to be the other way around. So Swagger has tools available through their website that you can take a Swagger document and it can create a client or it can create a server implementation. Now, how many of you think that it actually produces like code that's ready to ship? Yeah. It's not always the greatest. The client one is not bad, actually. So you can generate a PHP client from a Swagger document that uses curl, and it actually produced something that works and isn't that terrible. So if you want to get something like really quick out the door, you could totally use that. Then you would just have to kind of take that and plug in the authentication stuff, and you're good to go. There's also a server generation component, and there's even one that produces Lumen code. But unfortunately, it ends up looking like this. Not quite ready for production. Function null equals null, that one was kind of interesting there. I'm not sure what their template does, but so that one I wasn't too excited about. But I like going from code to Swagger, I think, personally, for the server implementation. There's also another project out there called Jane OpenAPI that generates PHP clients for Swagger services. And it uses a library called HTTP plug to create the client. And that library is kind of cool because you can plug in a Guzzle client to actually do the requests or other kinds of clients as well. And then when I was working on kind of setting things up for this presentation, I wrote a little library called Swagger Lite, which I thought was kind of fun. That's on GitHub under my account now. And basically it takes, it reads the document and can then generate, well, it actually doesn't generate, it just does it dynamically. It allows you to call the operations from the Swagger document, just pass in the parameters, not knowing where they go, and then it resolves them and puts them in the right place in the request. So that was kind of a little fun tool there. And What's cool about Swagger documents, I forgot to point this out. I'm going to go back to it because I think it's awesome, is when, is it in here? Ah. Okay, sorry, that was jumping around a little bit. When you define a operation in Swagger, I didn't put this here, but there's a parameter called operation ID, and you can actually give your parameter a name so that when you're generating a client later, instead of treating it just like a general REST client, you can actually reference that particular path and operation by a name, so you can kind of make it more like functions on a class. So I took into account that into the library thing that I was working on, and that's why I have, you can just call create assignment here, because in the Swagger document that I wrote for what I was working on, I made create assignment the operation ID. So it picks that up and reads it. So the code that I wrote, probably not production ready, but maybe a good starting point. And that's something that I'll talk about in just a minute. So when if you see in the schedule, my presentation was just called Lumen, Guzzle, and Swagger. But if it's not too late, Taylor, can we update the schedule to be APIs with Lumen, Dingo, Fractal, UUID, Guzzle, Open API, Swagger, Blueprint, and more? Would that be okay? All right. So what's missing? When I was kind of trying to explore this whole thing end-to-end with client and server side and Swagger kind of being the bridge between the two, there's a lot of holes. It's like a puzzle that you put out there that's almost done. You know what the picture is, but there's still a whole bunch of pieces that you haven't put in there yet. And I think what those pieces really are opportunities. So how can you help? I think you should start using Swagger if you're not already. Create a Swagger document that you publish for your service. You can find one of those tools that I've talked about and help out with it. They're all open source. A lot of those tools, unfortunately, are in kind of a maintenance mode only. The developers aren't actively working on them. So maybe there's some project out there that needs a new person to take the reins. As I mentioned earlier, this is a great time to get involved in the Open API initiative group because they are actively trying to develop the next version of the Swagger spec, so you can get your input in there. And I think there's even still more work to do kind of in the Laravel Lumen community about making it easier to develop APIs. I think what Taylor did with Laravel Passport is definitely awesome and a good step in that direction. There's definitely more things that can be done. So just to kind of drive home the points I've been making today, I've decided to sing a little song for you guys. I think it needs to be a little bit louder. Is that good? You guys hear me still? All right. APIs are hard. If you let it, you've got a trump card. Let's play it. I'll show you the way. You'll save the day. Make sure you get paid. Your service is deployed, but they're saying they're not overjoyed. It's confusing. Here is a tip that you can ship so your users don't flip. And we'll code like this. Let's annotate this method and I'll show you how to generate docs that are cool with tools like Swagger. With cool tools like Swagger. We've got tools like Swagger. Once you have a Swagger.json, the possibilities go on and on with tools like Swagger. With cool tools like Swagger. We've got tools like Swagger. I think I just heard a free bird, I think. We don't have the time. So I did that not only because I really enjoy music, but because now you won't forget to go read more about Swagger. So it's going to be stuck in your head now. So like I promised, there are a bunch of links in my slide deck here. I got 2 pages worth, so make sure to check that out. I'm going to be publishing the slides tonight. And just want to say thank you for listening. Hope that you learned something you can take back and apply. Thank you.